We're all familiar with the law of cosines from high school algebra. We want to use the law of cosines to show that cosine theta is equal to x dot y divided by the length of x times the length of y. So let's just review what the law of cosines tells us. If we've got two vectors that come out of the origin, a vector, say like that, and another vector, perhaps like that, we'll call one of them x, and we'll call one of them y. And we'll call the angle between them theta. And we're looking to show that cosine theta is equal to x dot y over length of x, length of y. Now, we can draw this vector here that joins x and y. We'll call this w. But if we're taking the physics interpretation of vectors, this is really x minus y. Okay. Now, the law of cosines tells us that the length of this side here, this length of w, is equal to length of x plus length of y minus 2 length of x, length of y, cosine theta. And of course, this is where the Pythagorean theorem comes from. The length of w squared is equal to the length of x squared plus the length of y squared. And that angle is 90 degrees, which makes cosine 90 0, and this whole nonsense at the end disappears. When the angle isn't 90 degrees, then of course this doesn't go away. Okay, so we've got this formula that relates x and y and w. So let's start by referring to w as x minus y. So length of w squared equals length of x squared plus length of y squared minus 2 length of x, length of y, cosine theta. Okay. Now, if we take this formula, and let's start by referring to w as x minus y. And let's remember that the length of any vector, let's say u, squared is equal to u dotted with u, which means we've got on the left side x minus y dotted with x minus y. Here we've got x dotted with x. These are all vectors, of course, plus y dotted with y, minus 2. And we'll leave that as length of x, length of y, cos theta, just for the time being. Okay, so when we open these brackets up, we get x dot x minus 2x dot y plus y dot y equals x dot x plus y dot y minus 2 length of x, length of y, cosine theta. And of course, we've got cancellation. The x dot x and the y dot y terms go away. And we end up with negative 2 x dot y equals 2 length of x, length of y, cosine theta. Oh, I forgot my 2. The 2's will cancel, of course. And so if we divide through by the length of x and the length of y, we get x dot y over the length of x, the length of y. I was a bit inconsistent with my arrows, but I want to make sure here that we notice that this is a dot product and not multiplication. And so the law of cosines shows us that for vectors, we do indeed have cosine theta equals x dot y over length of x times length of y.